All right, folks, we are now looking at chapter 3. And chapter 3, as I was mentioning just before I started recording this video, this is a really critical chapter in this book because it covers some of the fundamental precepts of what we call object-oriented programming. And object-oriented programming is a significant advancement in programming when it was first introduced because it allows us to basically find convenient ways to not have to repeat the creation of the same code over and over again. It's really the crux of it, right? So if like, the statement like, why reinvent the wheel, right? A wheel is round, it rolls, it gets you from one place to another. You don't really need to improve, the shape of a wheel. The wheel is a wheel. You might use different materials or whatever, but a wheel will roll and get you to where you're going. And that's kind of what we have going here. So the main topics for the chapter, you can see are listed right here at the beginning. And I do split this chapter into 2 weeks because I think it really deserves it. And I know some of the other instructors that teach this maybe squeeze this all into 1 week, and I think that's too much, frankly. So that's where I diverge a little bit from other instruction that maybe you guys have had in the past on this. Anybody that's a repeater here, and I know there's maybe one or two. But I will talk first about methods. So I'm going to talk about the first 4 bullets. And then next week, we're going to talk about objects and classes. And then the exercises that are assigned in that same fashion. So the first batch of exercises focuses on methods. The second batch focuses on objects and classes. The you do it exercises, though, however, focus on the whole chapter, right? And the whole point of that is you're reading the chapter and doing the you do it's as you go, right? And that's really what I hope you do. And I don't know how many of you are a fan of this author's writing style, but I think, for a programming book, she does a really nice job. And if you take the time and read it slowly, she really does actually a pretty good job of explaining everything. And she's really good with the terminology and how it's applied. So I'm going to go ahead and jump to the next page here. And let's first talk about what a method is. Now, any of you that have learned how to program in a different language first, and I know that's many of you in this session, so many of you have already had the Python class, for example. In the Python class, when we create a block of code that has a name attached to it, what do we call it?
A string, right?
No, Jabari, good guess, but no. Anybody else want to guess?
Can you repeat the question again?
Fair enough, Dennis. When I can create a block of code inside of Python and I give it a name, and then I can call upon that block of code by name, what do we call that in Python?
A function.
A function. Okay. How many of you have maybe had Python? I'm hoping if you had Python that you've learned about functions, or maybe you're learning about it right now for all I know. Or if you've had JavaScript, we also call named blocks of code a function. Inside of Java, we will call these a different thing. We will call them a method. And in fact, one thing that we do, and you've heard me say this many times, we create a program and we always add the main method to it so that we can execute the program. Anything that goes inside the main method will automatically run when the program launches. And that's pretty important. And you notice whenever we refer to a method, and you're going to see this as well, is that whatever the block of code is named will always be followed by a set of parentheses, with the parentheses existing to allow us to send information to that method to perform work with it. Sometimes it'll be empty, sometimes it will contain stuff. All right, but the long and the short of it is a method is a block of code that is encapsulated by curly brackets that will have a name and will perform a task, and then we can call it. So that's what this next little section is about. They talk about invoking it or calling it. So usually in programming, we say we're calling the method or we're calling the function. And you will at times hear me interchangeably use those words. And that's because I've programmed in so many different languages, and I know that some languages we call them methods, some languages we call them functions, some languages we call them subroutines, some, et cetera, et cetera. And so sometimes those words are synonymously used. So if you hear me say function, really I'm referring to a method in Java. So in Java, they're always formally called a method for whatever reason. Somebody came up with that. All right. Now, if I'm going to give you an example here, you're going to notice that, normally we write a class and then we have the main method. And the main method contains all the code that's going to happen. Now, this only works because built into the Java language is a piece that says, hey, when we start up this class file, look for the main method and do whatever it says. If I didn't have the main method, nothing would happen in the program. So even if I had these 4 lines of code here, nothing would execute. Java knows to automatically execute the main method. So the main method is one that we never have to call to run. It runs automatically. Any other one that we create, so in other words, I can create a block of code that looks like the main method. So in other words, it will have a name and parentheses. It might have some of this other stuff like public static void or private static void or private string, whatever. You can have all sorts of stuff in here, right? But it will have a name and a set of parentheses that may or may not have content. And then in between the curly brackets that follow will be a specified set of steps that when we call the name of the function, or the method, excuse me, it will automatically execute without us having to retype all those steps. So the first example that they're putting in here, this is a really nice one, is think about if you wrote a program that was to type perhaps a form letter and put content on a screen. And part of it might be that you always want the address of the company to appear at the top of the document or the bottom of the document. Now, it would be silly to have to type these lines of code over and over again every time you want to do that. Instead, what you could do, and this is what they are demonstrating here, is you can take that address part and move it out of the main method and put it into a separate method called display address. And I'm trying to find the example here. And here's the full-on example. So this is a really nice little example. So instead of me manually adding each one of these lines to the main method, I instead create a separate method, and notice curly brackets open and close. It's still public static void. These do have special meanings. We're not really too concerned about those right now. But more importantly, it is named. And usually you want to name it as to what it does. And this one's intelligently named display address. And then the parentheses. In this case, we're not sending anything to it. We're just calling upon on the method. So the main method will call it. It'll come down here, execute the code, return back to the spot in the code, and move on to the next statement. So now if you can think, if I do this often in this program, it's going to become very helpful for me to have that predetermined block of code with a name on it. And then every time I want to display the address, I just say display address parens semicolon, and it's on the screen. That's all I have to do. Now, in this case, there's only 3 lines of code being put out, but it could be 50 or 100 lines of code. It could be, right? And could this method, let's take it a step further, could this method call other methods? You betcha. In fact, it's already doing that. And here's the proof. This command here, print line, is in essence a method that is part of the out library of the system class. This is how this reads. So this is a class file that has a library within it called out, and then that library has a command called print line, which knows how to take whatever you put inside the quotes and then feed that back to the screen. So you don't have to do that manually. You do it automatically by just calling that command. So in essence, print line with parentheses is a method itself. Isn't that interesting? So we're using the main method to call it. It repeats a set of actions that we can just call upon by name, and therefore allows us to repeat our code very, very easily and succinctly with a very minimal amount of additional coding. And
Can I interrupt?
Please, Dennis, go ahead.
In relation to Python, where it reads from the top to the bottom, is it because Java is compiled that you don't have to put that other method above or below the main method?
Yeah, well, see, Python is different, Dennis, in this regard. in order for the main method to execute in Python, you do have to call it at the bottom of the program.
Right.
Right. Yeah. But once you get past that, it doesn't matter where the methods or the functions are declared. It will find the name block of code and execute it.
Is it because it's compiled?
It's not because it's compiled, it's because of the architecture of the language. So
Okay.
because Java has an automatic main method, I never have to call it. That's where Python is different. And it tells you a little bit about the architecture of Python, that Python has a main method not by convention, not because that's how it operates. It has a main method. That's because that's how all the programmers decided to do it that way.
I was kind of more related to the order, that putting the code after the main or before the main doesn't really matter.
No, it does not. That's an excellent question. So if I wrote the main method and put it at the bottom of all my code, and this method was written above it, right? The question is, because you're right, in Python it wouldn't find it, right?
Right.
Here,
And we
here,
were done
here
to
it will.
find.
Here it will find it. And that's kind of interesting, right? Because once it's inside those curly brackets and it's named, it's now taken out of the sequential flow of the program. It's treated as a separate entity. And this is what one of the main concepts is as well. You know, the code becomes encapsulated inside these curly brackets, and then we can call it from anywhere and execute it. Now, it might not seem very apparent when you get started on this. Like, why do I need this? Is this really important? Like, yes, it is. Because when higher level programming is all about not repeating the work that you've done in the past, you know, and you're going to find, pre-built methods that you're going to use, like print line, that do work for you very quickly and efficiently, or you're going to have methods that you built that do specific functions that serve your needs or whatever company you're coding for. And so I think this is really kind of a nice little example, and I think they do a nice job of explaining it. And I think I've covered, believe it or not, most of the major precepts of what I want to cover here already. But I do want to talk about like the pieces. So let's get into this because it's not too much more to cover. The first thing that we're going to notice is they have what we call method headers. So in other words, this whole string here, in public static void main, for example, is one that we learn to memorize. But there is a meaning behind each one of these words. And the public means that it's accessible to anything within the program and anything outside the program, provided the program is also public. So I can have another program in the same folder calling upon a method in this program and use it in the other program, just because they're in the same folder. And I want you to think about that for a sec. That's pretty cool. So you mean, hey, I wrote something in one program and my other program's in the same folder, so I can call the method from the other program into this program. Wow, that's pretty neat. And I don't even have to open up the other file and do it, just as long as I know what's in that file. So that's a really important thing. The type of information that exists in those four words are these four things. So optional access specifier, so that would be public or private, typically is what you'll see in the first position. A return type, for example. So aside from that, static means that it is not necessarily returning a value and it cannot be changed. But what you'll typically see in these positions is either what type of value it's returning, if it's returning a value, and what ultimately the name of the thing is. So the identifier is the name, and then finally the parentheses are the piece that we're sending in information into that method. Display address doesn't require it, but you could imagine that maybe if this was like a customized address output thing, maybe you could feed in a piece of information here that would then feed into a variable here and it would carry forward. We'll look at that in just a little bit. Don't get too mired in that one. All right, so they go through that explanation here again. Public means any program can access it. Static means that it doesn't require an object to be created, so we're not instantiating an object from it. Void means that it's not returning anything. If something other than void is here, it'll be the data type that's being returned. So it could be a string, could be an integer, it could be a double, for example, and then the name. Now, there are times when we do these methods and we will talk about that return type. So here, nothing is being returned, but what you will notice, and I think this is where they go next, and of course they don't. Doesn't fit with my presentation. Sorry, author. I guess they're not doing that quite yet. All right. So what you will see, though, is when we start doing return values, that this will change to whatever value is being returned. So it's indicating that the value or the type of data that's being returned, so that wherever you're returning it to will go to the right place. All right. So they have, the first you do it here, and I'm not going to code through it, by the way. I kind of want to get to the next topic, which is parameters. Now, it's interesting, parameters, or what some people will call arguments, and there's actually a formal way to look at this, by the way. It's technically an argument if it's in the same line as where it's being called from, and it's a parameter when it's being received, technically. People will use those terms very interchangeably, but that is the part that ends up in between, basically, like when you do a print line, it'll be the part that ends up in between the parentheses, and that's where they're going with that. One of the reasons people use methods, by the way, especially if they're in external files, is because it allows you to hide from other coders what you're doing. Because, frankly, do we really care how print line works as long as it works? And the answer to that is typically no. So, one of the reasons we write methods is to simplify our code creation and not have to worry about the details about what each method is doing. Yes, you can look at methods, but typically once you've created a method and it works, you leave it alone and just call on it as you need it. And that is called implementation hiding. And all we really need to know about that method is how to interface with it. So in other words, what data does it need to operate, or does it need any? Can we just call it and it does whatever it does? In some cases, the answer is yes to both, which is kind of an interesting thing about Java as well. Now, if they go through this example now of sending, for example, this thing called calculate gross. So this is a method that's being created. You'll see the public static void. That'll be most often what we do to start with. We give it a name, and then inside the parentheses, as we declare the method, we are indicating the data type that it needs to receive and a variable name for the information once it gets inside the method. So the example that they'll use here is they have this calculation for calculating gross wages, for example. So if I was to call this from another part of my program, I would just simply say calculate gross, and I would put inside of the parentheses how many hours I've worked. Maybe I worked 37.5 hours, and that's what it would send into there. That would land into this variable, and then this variable would be used for the calculations inside this block of code. So when I call this from my main method, all of these steps will execute, but it is expecting that I'm sending it the hours inside the parentheses. If I don't, it will fail, because this method requires that I pass forward that information. All right. And I know I'm kind of going quick here, but they demonstrate, for example, what kind of stuff you could put inside there. So you could hard code a value. Now, this is in this case, they're calling the method, notice, with an integer instead of a double. What will happen in this circumstance, and it indicates that integer will automatically be promoted to a double. They'll add 0.0 to it and then do the calculation. It will work. It's not recommended. It's better usually if you can send it in the format that it accepts. So in this case, this is a hard-coded numeric value. And yes, you can do that. You can hard-code numbers in. You can also do math right inside that if you want. It's going to do the math first and then send it. What is considered better, though, is for you to either set up constants or variables and then put those inside there. So in other words, you might have a user say, how many hours did you work this week? And they would type it in, it would store into my hours, and then my hours would be sent there to calculate the wages. All right. It's also possible to feed, and this is where it gets weird, to feed the output of one method into the input of another. So that's what's going on here. In this case, I might call a different method that gets the gross hours and then just feeds it in here directly. You know, we're not quite at that point yet, but that's a possibility. I just want you to be aware that you can do that. All right. What I always like is to look at these. So let's look at an example of how this might actually operate in reality. We start with this class, you know, the whole program is called demo gross pay. In the main method, we've set a couple of variables, the hours, 25, your hours work, 37.5. And then we notice that down here, we have a named block of code called a method, right? You see the public static void, it's not returning anything. It's named calculate gross, and it's expecting to receive a double, which will be your hours. All right, so up here in the main program body, the first run of it, we call it once, and we hard code 10 hours into it. So this will send 10 hours down here, and it will do the stuff, and then it'll print this out on the screen. The next example, it's going to read the variable called hours, which is 25, send it down here. You know, notice the 10 and the 25 are both integers. Those will be promoted to doubles, and the math will continue, and the output will happen. In the third example, right, the third time they call it, now they're pulling it from the other variable, and this one's already a double, and it will send it down here. So the 37.5 ends up here, and wherever hours appears in the code here, that will be substituted in. And then once again, it'll do the math and output the message. Okay, that's the anatomy of how it works. That saves us the need to write all of these lines of code over and over up here. So these 3 lines in essence are, you know, what are 4 lines each, right? So it would be 12 lines of code up here instead of, you know, calling this. So the advantage here is this is a repetitive action, so why repeat the code? This is the why we do it. And so this is the basic anatomy of a method, folks. And they go on and they talk about a couple of things here. But the next part of it is, what if that method accepts more than one input or more than one parameter? And in this case, they changed it. So for example, they upped the inputs to include both your hours as a double and your rate of pay as a double. So, right, so you have workers that have different gross hours and they have different rates of pay. Not everybody makes the same pay. Your manager might make more than somebody else or whatever. So this allows you then to both send in both of these items. And then if we look at the example version of that, and yes, I know I'm skipping through it pretty quick, but I want to get to the examples. All right, well, in that case, that was the example, I guess, sorry. But if you can imagine that you could just substitute the same thing, but from the calling part of the program, you can send in hours and the hourly rate. So like maybe I would be 37.5 to send in here, and maybe my rate of pay is, I don't know, $500 an hour. Sounds good to me. That's what I would put there, right? And it would calculate it out and then put it on the screen. In the next section, you'll notice what they do is they're also now ramping it up so that methods could include what we call a return statement within them. And so if you look at first the anatomy of that, if I did, we looked at display address, that doesn't return anything. So this position here right before it says void. In this case, if I did like a get age, here this one is indicating just by the way it's named that this is going to return to me an integer value back to the position where it was called from the main program body. Now, if you think of how Python works in this regard, for those of you that have already taken it or are currently taking it, in Python, you return a value and it doesn't matter what type it is because Python doesn't care what goes into a variable. The problem is that Java does. Java is what we call a strongly typed language. So when you're sending back an integer, you better make sure that you're sending it into a container that can hold it or manipulate it or do something with it. And so this one returns nothing, so it says void. This one returns an integer, so it says int. This one returns a Boolean, a true false, or it could be a double, or it could be a string, or. Any of the data types that are valid could be listed in this position, but it indicates what type of value it's returning. And so for example, if we were to take that previous example of calculate gross and we're sending in the hours and the rate of pay, maybe instead of having it directly put the information on the screen, all it's doing is the math. And now it's going to return back to the main program body whatever the calculation is. And this is going to, because we're setting this up as a double right inside of here, we know it's returning a double. So that the statement is indicating public static double in the name and the parameters. So this is the return type. So whatever you're returning in the return statement, and notice return whatever variable or calculation or string or whatever you're returning is listed here. That data type has to match this, otherwise it will not compile. That's pretty critical. And you can kind of look at a bunch of different things. So you can return hard-coded numbers, you can return calculations, you can return the results of other methods if you wish, or whatever you calculated, a constant, a variable, whatever it is, you can return it, but just make sure the data types match. All right. The one little thing that's kind of weird about returning values, and this is probably the hardest part of it, is whenever you are sending values to a method, so like calculate gross, if I'm sending a couple values to it, I'm sending my hours worked and my rate of pay. And whatever those numbers happen to be, some math happens, and then this will return a value back. And I think we already determined it would be a double. So that value has to have somewhere to go. So if this is returning something, it can't just sit in midair. On the left side of the assignment statement, you have to put a variable or something that can hold that value and then do something with it. So that's one thing. So you can store it in a variable and then output it to the screen or do further math with it. Some people will kind of operate these on the fly. So this is a valid approach, putting it into a variable, but this is also a valid approach. I could just directly say system out print line, my pay is, call the method directly with the hours and the rate of pay right here, and that'll go off to that method, do the math, return the number, and then print it on the screen directly. Not too dissimilar from what we do in Python or JavaScript, by the way. Very, very similar to both of those languages. All right. Now, this little piece is about as far as I want to take it. I think that's enough to know to get the homework done. I would implore you that if you have plenty of time on your hands, watch my full lecture video on it and read the chapter really carefully. And then as you do the you do it's, think about some of the stuff I just mentioned here and how it's operating. And the you do it's are designed to demonstrate those features, all of those features. So this is working with methods, folks. And I'm going to actually stop this video here because I want to publish this as a separate video, just the lecture part, and then we'll come back and we'll get to code. So this video will stop here.